Welcome to Section 5, where we'll talk about using Spring Boot alongside Spring Security to implement common security specifications. The videos in this section will cover OAuth2 with Spring Security, and how to set up authorization and resource servers, and using JSON Web Tokens with OAuth2, as well as single sign-on. In today's world of massively interconnected applications and big data composed of private and sensitive information, security plays an imperative role. Often security is overlooked or implemented incorrectly because of the complexity involved. Spring Boot helps ease the initial complexity of securing your application by providing the proper dependencies and auto-configuration. In this video, we'll discuss using Spring Boot Starter Security and Spring Security OAuth2 to implement OAuth2 authorization into our application. In this video, we'll cover OAuth2 with Spring Security, how to set up an authorization server with Spring Boot, protecting and granting access to resource servers, and using the OAuth2 REST template in a client to gain access to resources. OAuth2 is currently one of the most popular approaches to authorization. OAuth2 is a standard, not an implementation, but luckily for us, we don't have to implement it ourselves, as Spring has already done that for us. If you aren't familiar with OAuth2, I suggest reading more about it and then coming back to this video. You can find more information and documentation at oauth.net/2. Before we get into the nitty-gritty, let's look at a high-level overview of what we're trying to accomplish. In this example, we'll be describing OAuth2 with a client credentials grant type. This grant type is good for application access where the application is confidential. The flow we are attempting to achieve is this. The user makes a request with their browser to our simple service. Our simple service then requests a token from the authorization server by passing it the client ID and secret. If successful, the authorization server will respond with a token. This token is then sent to the request to the resource server. This resource server represents the server that hosts a backend API to retrieve data. The resource server will then retrieve the user info from the authentication server and allow access to the resource server's API. The response will then be sent back to the simple service and then the user's browser. Now that we have a good overview of what we want to achieve, we can begin by looking at the authorization server. Besides the Spring Boot Starter Security dependency, we'll also need to add the Spring Security OAuth2 module. This module will provide us with an OAuth1 and 2 implementation for Spring Security. With that added, we can start configuring our authorization server. Take a look at the authorization server OAuth config. This class uses the enable authorization server annotation, which will create the authorization server and OAuth endpoints that are needed. Spring Boot then has auto configurations that will allow us to specify properties to get our server up and running quickly. We want to create a client ID and secret that our simple service will use, so we add the properties security.oauth2.client.clientID and security.oauth2.client.clientSecret with the values client and secret. The check token access property is set to the spell expression is authenticated, so only authenticated users can check token access. One thing to note is we're setting the context path on our applications because everything is running on the local host. The context path helps with keeping the correct information in the cookie. In our main application class, we also have the authorization server marked as a resource server with the enable resource server annotation. This is because the authorization server is also hosting a resource, namely the user endpoint, that's used to retrieve the user information for our main resource server, which we'll see shortly. Let's start the authorization server and look at some examples using curl. We'll get the token from the authorization server with the following curl command. This call is hitting the OAuth token endpoint with the client ID and client secret we set in the authorization server application properties. Let's try and access the user endpoint we added to the authorization server. We get an unauthorized error stating we can't access the resource. Let's take the token we got from the token endpoint and add it to the authorization header for this same call. We now have access and successfully got the user information. Let's move on to the resource server. Like the authorization server, it needs to use the Spring Boot Starter Security and Spring Security OAuth2 dependencies. The resource server config uses the enable resource server annotation, which sets up a Spring Security filter that authenticates requests by using the token that's passed along. If you want to add additional method security, perhaps to check specific roles, you can enable method security with the enable global method security annotation. We need to add some properties in order to let the resource know where it can validate the token. In this case, we have set the security.oauth2.resource.userinfo URI property to the user endpoint we set up in our authorization server. If the token that's passed to the URL is valid, then the resource server will be given the user information and access will be granted to the resource server's controller. In the resource controller, we have two endpoints, our home index that returns the word hello, and a person endpoint that returns a person object. We can test this using curl. We use the same call to the authorization server that we just made to get a token. We can then use that token to hit the person endpoint on our resource server to retrieve the person data. Now we'll put ourselves in the shoes of a third-party API accessing our resource server. This will be our simple service. This service will also need the Spring Security OAuth2 module. This is to gain access to the OAuth2 REST template, which will help manage our token requests and calls to the resource server. We're using the Enable OAuth2 client annotation in this configuration, but it's not a necessity in our application since we're using the client credentials grant type, which is simpler than the authorization code grant type and doesn't need the functionality that this annotation provides. In the application.properties file, we can add the information to retrieve a token from the authorization server. We specify the client ID and client secret that we set up in the authorization server. The endpoint to get the token is set to the access token URI property, and we set the client authentication scheme to header. Other possible values are form, query, and none. Finally, we are setting the grant type to client credentials. In the simple controller, the OAuth2 REST template is auto-wired so we can use it to get the token from the authorization server, then make our request to the resource server with a token passed along in the header. Make sure our authorization and resource servers are running, then start the simple service. We can navigate to localhost port 8080/API/person in our browser, which is the endpoint on our simple service. In the simple service logging, we can see that it makes a call to the authorization server at the OAuth token endpoint. In the authorization server logs, we can see that the authorization was successful, meaning a token was returned to our simple service. We can see that the simple service then makes the call to the resource server's person endpoint. If we take a look at the resource server logs, you can see it successfully makes a call to the user endpoint on the authorization server, and then allows the request to the person endpoint and returns the data which we see in the browser.